Hi guys, and welcome to another online lesson in National 5 Chemistry. Today we're going to be looking at reactions of alkenes. Alkenes are far more reactive and they undergo far more reactions than alkanes, so we want to have a look at why that is and what types of reactions they undergo. By the end of the video, hopefully what you should have grasped is an understanding of the types of reactions that alkenes undergo and also how and why they undergo those reactions. You should also be able to draw these reactions out. Firstly, we need to look at why are alkenes so reactive. I've already mentioned that alkenes are more reactive than alkanes. We know that alkanes, particularly the shorter alkanes, are very reactive with oxygen. In other words, they combust to give lots of energy. But that's pretty much all that they do. They do more things than that, but that's pretty much all we are interested in. Whereas alkenes undergo a lot of different types of reactions. The reason for that is that they have a functional group. What is a functional group? I hear you all cry. Well, we've already met its functional group, and its functional group is the thing that makes it an alkene, and that is the carbon to carbon double bond. Okay, that is the functional group. It's called a functional group because this is the part of the molecule which gives the alkene its function. In other words, allows it to do what it does. Okay, so this is the thing that allows the alkenes to be reactive. The reason it allows it to be reactive is because if it has a carbon to carbon double bond, then the molecule is what we call unsaturated. In other words, if that double bond were able to break, then we would be able to fit more things onto that molecule. And that's exactly what happens in any chemical reaction. We're trying to change the molecule in some way. The difference between the alkenes and the alkanes, of course, is that they miss that double bond and therefore that molecule is saturated. In other words, it's full. So we can't fit any more of anything onto that. Okay? There's no double bond to break, and so they are much less reactive. So let's have a look at what that actually means in practice then. Well, alkenes undergo three different types of reactions. These are called addition reactions because we're adding something across the double bond. And the first thing we're going to look at is something called a hydrogenation. It's essentially, as the name might suggest, adding hydrogen across the double bond. So if we take alkene, ethene, okay, the most simple alkene, and we react it with hydrogen, what we're actually saying is we've got this alkene and we've got a hydrogen molecule, and what's going to happen is that double bond is going to break, and it's going to cause what I like to think of as little half bonds coming out. Okay, if you were thinking those two half bonds tying up again to make the double bond, you've got these little two half bonds. What can happen here is that this bond is going to break and you're going to have two little half bonds here, and the hydrogens are going to be added across that double bond. Those little half bonds here are going to join up with these little half bonds here, and what you're going to end up with is a single bond, and then the two hydrogens you had to begin with, and then the 2 hydrogens that you have added across the double bond. And that makes an alkane. So what you've got is a hydrogenation. Alkenes undergo hydrogenation to make alkanes. So if you've got ethene, that's going to make ethane. If you've got propene, that's going to make propane. Okay, fairly straightforward. Hydrogenation, you're adding hydrogens across, so you're making an alkane. Halogenation, that's the second type that we can go. I'm going to start off with the same molecule that we had. The mechanics of it is exactly the same. Okay, the double bond is going to break. Halogenation is where we take a halogen. Halogens are group 7 of the periodic table, and you'll learn more about those in unit 1. But if we take a halogen, for example, chlorine, again, chlorine is a diatomic element. That means that it travels in pairs, so you've got a chlorine molecule. And exactly the same thing is going to happen. That double bond there is going to break. You're going to have a little half bond coming out. The same thing's going to happen here. And these are going to join up. So what you're going to end up with is a molecule that looks like this. You're going to have a single bond, the 2 hydrogens on each carbon that you had to begin with, and then the chlorines added across. The last thing is a hydration. Hydration is where, as you might suggest, if you're dehydrated, you take water and then you become hydrated. The exactly the same thing happens here. So what you're going to have is you're going to have your alkene, ethene, and it's reacting with none other than our favourite water. Water, as you know, I'm sure, is H2O. So that's what it looks like. It's got 2 hydrogens and an oxygen. Slightly different. The alkene's going to do exactly the same. Double bond's going to break, and you're going to have 2 little half bonds. Now what's going to happen here is that one of these bonds is going to break. Doesn't matter which one. And what you're going to end up with is a half bond here and a half bond here, and they're going to match up. So you're going to end up with a molecule that's got a single bond, the 2 hydrogens that you had to begin with, and then on one of them you're going to have an OH, and on the other the hydrogen. Now that's creating a molecule called an alcohol, and we're going on to talk about that in a little bit. Okay, we're going to talk about that in maybe a week or so's time. So don't worry about that too much. Don't worry about what this is. We will talk more about that. But that's how we make it from an alkene. It undergoes hydration. We add water to it. So, with that, and don't forget, you can go back, pause the video, rewind it, have a little look, slow it down, see what I was talking about, have a go at these. Okay, I'll give you some time to pause the video and do it. I'm going to go ahead and do it just now. Okay, I hope you had a go at these and you got them right. Let's have a look. When propene undergoes hydrogenation, what molecule is formed? Well, we're adding hydrogens across the double bond, so I'm sure most of us will be able to get that straight away, but just in case we can't, if we start off with propene and we have our hydrogens in there, the double bond then breaks and we'll have, I'll add my hydrogens nice and quickly, a double bond breaks, we're adding 2 hydrogens, because remember hydrogens travel in pairs. What you end up with is the hydrogens being added across the double bond. So you end up with propane, the alkane version of the alkene. So it's propane. And I hope you got that. Draw the structural formula of the product of the reaction between chlorine and butane. So butane, again, if we have the double bond here, I'm not going to add in all the hydrogens, I'll just add in the hydrogens here, here and here, okay, but these would be full of hydrogens. And we're adding chlorine molecule. So exactly the same thing's going to happen, that double bond's going to break, and our chlorines are going to be added to each of those two carbons. So we're going to end up with a saturated molecule full of hydrogens, except where that double bond was. So we end up with something that looks like that. Pentene undergoes hydration. So hydration, we are adding water. Pentene, pent is 5. So again, I will just very quickly do this. We're adding water. Now water is our H2O. The double bond is going to break. We're going to add an OH to one and an H to the other. 2, 3, 4, 5. Now you'll see that a common theme is that all of these become saturated. Okay, so they become full of either hydrogens or something else. Okay, and that's what we end up with. We end up with an alcohol, and we will learn how to name that alcohol in a week or so's time. I hope that's cleared that up. It's a lot to go through. The only thing that you need to remember is that alkenes can undergo reactions by breaking a double bond and adding things across the double bond, and this is called an addition reaction. And they can go through lots of different types, but these are the 3 main ones that we're interested in. Hydrogenation, where we add hydrogen across. Halogenation, where we add a halogen across it. Or hydration, where we add water across it. Okay, I hope you enjoyed that. I hope you understood that. If not, just let me know, and I'll see you next time. Thanks.